Hello everyone, welcome back. So this is a part 2 video of 2.2, determining volumes by slicing. So we've been talking about another benefit of using integral. It helps us to find out not only the area, but also to find out the volume, correct? So to find out the volume, we talked about 3, right? So integral, it helps us to find out the volume. And then there are 3 different approaches: slicing method, and washer method, disk method, and washer method. So in this video, I'm gonna focus on washer video. And if you wanna take a look at slicing and disk method, watch the previous one video so that you can check it out. So washer method, I'm gonna compare the difference between disk and washer because those two methods have a commonality. The cross-sectional images is always a circle. And then the different thing is you're going to deal with the one function, but in washer method, you're going to deal with 2 functions. So let me show you the table so that you can have a better concept to see the difference and commonality between disk and washer method. So keep in mind that we are trying to measure the volume of the given curve. So let's take a look at it. So I'm gonna just take a, at pi. So if you remember in disk method, you have, let's say function, and then you can rotate either x-axis or y-axis. And then they're going to, when you rotate the function, either y or x, they're gonna create a circle cross-sectional image. So everybody knows that the area of circle is a pi r square. So you have a pi r square, which is a function that is the radius. And then dx, this is a rotating about x-axis. But if you're rotating y-axis, we talked about it, every function should be written by y variable. So pi, the function, but it should be written by y, and you're going to take the integral in terms of dy. So that was the disk method. So what is a washer method, right? So washer method, you are going to have 2 functions, and then you are going to rotate them either x-axis or y-axis at the same time. So here is the image I'm going to show you. So do you see that I have one is a g function and another one is f function. And I'm going to rotate those 2 functions about x-axis at the same time. So the red one gonna create large circle. And then if you rotate this horizontal line, they are going to have the same size of the circle. And then what happened is we are looking for the area between them, correct? So that the volume we are looking for is the between. So if you think about the image, that's what 3-dimensional image look like. I found out that since you're rotating 2 functions at the same time and we are looking for the between volume, the hole, there will be a hole in the center. We call that is capacity, okay? So what happened is whenever you are dealing with 2 functions, you're going to find out the large circle cross-sectional image minus a smaller sectional circle images, subtract them so that you can find out the volume that we are looking for in this image. So the one characteristic of the washer method, there is a hole in the middle. So same thing we talk about in chapter 2.1. When you're looking for the area between 2 functions, you're going to find out which one is a larger height function and then smaller height function. You're going to subtract them. And then same thing, pi r square. You're going to subtract the larger circle minus the smaller circle. You will get the between circle. So that's the volume of that images. So I'm going to finalize it. I'm going to show you all the information. Same thing, you could rotate either x-axis, y-axis. If you rotate about x-axis, those are 2 functions, all the functions should be represented by x variable. So you're going to take the integral dx, and then you're going to rotate the function around y. so that you have to change whatever the function in terms of y variable. So that's the function we call disk method. Oh, sorry, washer method. Because it looks like a washer machine, you keep circling, there's a hole, so that you can take a look at those. The two functions very similar what we have done, the area between two curves. Okay, so let me go up a little bit. So that's why the washer method, you're gonna rotate two functions at the same time, and then you can rotate it either x-axis or y-axis. So take a look at which one is gonna be f. You have to identify which one is f and g. That's an important step. And if you rotate y-axis, you have to modify whatever the x function in terms of the y variable function. So let's take a look at that example. Okay, so very understandable topic. I hope you guys are excited to take a look at the following question. Here we go. So find the volume of a solid form by revolving the region bounded by graph. So we have here two functions are going and they're rotating x-axis. Boom, boom, boom. We're gonna use a washer. Disk is not gonna work because they have two functions. So we have to just write it pi, right? And then a to b, you have to define which is gonna be the large radius function minus g of x smaller function, and then dx, you can find out the between volume, correct? So that's what we are doing, especially this is when you're rotating x-axis. So here is the image. So I do have y-axis, I do have x-axis, and then y equal to radical x, this is look like, this is y equal to radical x function. And I have a y equal to x function that's gonna be something like that. So you have this two function and rotate it about x-axis. So what happened is the large one, if you rotate this one, it's gonna be something like that, right? And then if you rotate this one, it's going to be something like here. It's a little bit smaller. And then we are looking for the between function. So as you see that, it's a little bit hard to imagine, but you can see easily which one is a higher function. Between these two, this is always higher than the second function. So quadratic function is always higher, right? So if you look at that, the quadratic function is always higher than the radical function. So therefore, this guy is going to be f of x. This guy is going to be g of x because we're going to subtract from f minus g. So you need to check the height. So f of x, which is x second, y equal to x second, height is greater than g function, y equal to radical x, correct? So now set it up. You're going to set it up, set it up, set it up. So the function is going to, volume will be pi from where to where? Ooh, do we know the a to b? So they didn't give us. From here to here, we need to find out a to b. So to find a to b, we need to set it up f of x equal to g of x. So you remember? So let's find out the a and b. So smaller. So then we have radical x equal to x second. And I'm going to put the radical on both of sides so that it is going to be just x because the radical cancel, x to the 4. And that means x to the 4 minus x equal to 0. X to the third minus 1 equal to 0. So in this case, you have x equal to 0 and x to the third equal to 1 means x equal to 1. So you have 0 to 1. So we got it. We got it. This is going to be 0. This is going to be 1. So we have now exactly from 0 to 1. Because think about it, this one, x is third equal to 1, x should be 1. So we have a 0 to 1. And then continue the gf function. We prove that this is x to the second f function. Second power minus g function. Second power dx. So that means pi 0 to 1 x to the 4, cancel, x dx. Now take the integral. So we're gonna get, so I have a little mistake, right? So I have a very bad mistake here. Let's look at that. This is the f function higher. So this one should be f. Why did I say this is a g? Sorry about that, guys. So this is the f function because it's a higher. This quadratic was a smaller. So let me just, this is the f and g. So let me change the order. Oopsie, oopsie, oopsie. So let me change that order. So let me do it again here. So the f is actually radical x to the second power, correct? And then minus the g function x to the second. You see that this is the higher, the radical. So now we got it. This is going to be x minus x to the 4. That's the right order. So we're going to take the integral finally. Pi x to the second over 2 and minus x to the 5th over 5 from 0 to 1. So you're going to do capital 1 minus capital 0. So pi 1 over 2 minus 1 over 5 minus pi, whatever it's going to be 0. So that's going to be the 0. So once you calculate it, common denominator 5 over 10, 2 over 10, gotcha. 3 over 10 pi. This is the volume between two functions. Beautiful. We got it. How you feel? Does it make sense to you? I'm not using any fancy technique, guys, right? So we are building up the concept from the previous concept. We already talked about how to find out the area between two functions, subtract from larger height minus a smaller height. And then this is a volume, so the pi r squared, because you have to consider the addition, all the adding of the cross-sectional image. So that's the volume. And then larger volume minus a smaller volume, you will get the between volume. So that's what we got in here. Awesome, awesome, awesome. So I'm going to keep going. The second question. So in this time, okay, we have a two function. In this time, we are rotating about y-axis. So what do you remember Washer method? If you rotate y-axis, so you have to find out y in terms of f function minus large, so everything y, and then dy. This is y-axis rotation. So let me draw the image. So we do have, so let me draw this one a little bit on the middle. So this is y-axis, this is x-axis, y equal to x is going to be that, right? This is y equal to x, a linear, and I do have, oh, my graph is not great. So we do have y equal to, okay, that's better. So we have, we do have, and I'm going to bring this one a little bit. Okay, let me get rid of it. So we do have the y equal to, okay, that's better. So this is y equal to x. And then we do have y equal to x the second power. We are looking for the volume, right? So think about it. If you're rotating the y equal to x, it's going to be large circle, right? So the whole bucket. And then if you're rotating the second one, you know, around the actually we are rotating, yeah, y-axis. So I rotate the y equal to x the second power. So this is the y equal to x the second power. And then you are going to rotate y equal to x. This is going to be something like this. Right? So we are going to, so let me draw a little bit. So you're going to have a hole. So you have this image. We're looking for this between volume. Okay? So we are looking for that volume between two functions. So y equal to x anyway, create like this hole. And then y equal to x a second is a little bit smaller. We are looking for the between, correct? So there's a cavity, there's a hole. Cavity, okay? So they didn't give us the height. So let's find out the height. And then they're rotating from, y-axis. So from here to here, we need to find out the height. So to find out, find the C and D, we're gonna say f of y equal to g of y. Because they're rotating y-axis, everything should be in terms of the y variable. So let's take a look at it. F of x is what? Y equal to x. And then let me just say y equal to second power quadratic because that looks higher. But then if you solve for, right, you're going to solve for x so that y radical is going to be x. This is going to be your new f of y equal to radical y. Likewise, g, y equal to x. You're going to solve for x, just x equal to y. So new g of y is y. So let's take a look at it. Your y-axis right there. So if you look at the y-axis, compare this one and this one, right? One is this one, purple, linear. Another one is the black, quadratic. So if you look at the y-axis, based on the y-axis, the quadratic is always higher. Don't you think so? So the quadratic is a higher height. So therefore, f of y is greater than g of y. We can check visually. Are we okay with that? So look at this red line. This is the height. That is the height. Always the red, the black is higher than purple based on the y-axis. So therefore, you can set it up f minus g as well. So once you set it up, everything, once you check it, I'm going to make it smaller. So because of that, we can now solve for C and D. So f of y, radical y equal to y. So you're going to solve for y. Square root both of sides. So y equal to y second. Y will be 1. So it's going to be from 0 to 1. So this is a 0. Obviously, this is 1. So the volume will be 0 to 1. F of y, radical y to the second, g of y, that's y to the second. And you're going to take the integral with respect to y variable. So then this is cancel. This is the cancel. We have y minus y to the second from 0 to 1 dy. So that means y to the second over 2, y to the third over 3 from 0 to 1. Actually, I forgot always a pi. Don't forget that, the pi. Here we have a pi, right? And then that means f1 minus f0. So pi 1 over 2 minus 1 over 3, and everything's 0, right? So therefore, you're going to find out the common denominator, then 3 over 6 minus 2 over 6. Gotcha. 1 over 6 pi, that's the volume we found out. So this is when you rotate y-axis. Change that, okay? Change whatever the x in equation in terms of y. Then you need to find out the intersected point to find out the height from where to where, from 0 to 1. And then check it out which height is higher, so that f, the quadratic was higher, so that f minus g, f is going to be the radical y, and then minus y. Are we okay? Yes. So I hope you're getting better. I'm going to just do 2 last questions to practice and to help you. All right, so here we go. So in this question, we are looking for volume. And then here is the function y equal to x to the 4, y equal to 81. So definitely the quadratic one, x to the 4, this is this shape, and this is y equal to 81. We are looking for the volume that purple area, because when you rotate y equal to 81, that's going to be the same circle. And then this one is going to be, whole circle. So actually, I made a mistake. This is the when you're rotating the x to the y4. And this one is going to be the smaller one. And then you're going to subtract, there's going to be the whole. So we are looking for the between. So that's going to be something happen. So we are looking for a little bit ugly shape, but we are looking for the between volume, of those two functions. So thank God here we have to rotate about x-axis. So when you rotate x-axis, which function is a higher, right? So when you look at that, this one, y equal to 81 is always a higher than the quadratic one, correct? So therefore, I believe this is going to be the f of x. We have to compare the height. And then that's the size of the radius of circle. So the circle, you're going to create it. This is the large one minus the small one. And then, this is always higher. So you can set it up better and better, but I'm going to do up, just copy this because we already know the formula. So here, this is going to be 81. This is going to be x to the 4, correct? So therefore, it is rotated about x-axis. So we found out this is f, this is a g. Do I know the interval? No. So we have to find out the interval from where to where. So to find out a to b, we have to set it up. F of x equal to g of x. So f of x is x to the 81. 81 equal to x to the 4. So if you solve it, x is going to be 3. So this is going to be 0 to 3. So finally, volume 0 to 3. Excuse me. And then larger one is 81 minus the second. And then x to the 4 to the second, dx. So you're going to take an integral of that function. So 0 to 3, 81 times 81. Ooh, it's a big number. And x to the 8 dx. Take the integral 6561x minus x to the 9 over 9 from 0 to 3. So you're going to calculate it a little bit ugly number. Minus x is a 3 here. 9 over 9. And then minus a 0. So if you're plugging in that equation into the decimal, don't forget the pi. Why am I keep forgetting pi? So there's a pi originally formula. So pi here. So you're going to calculate all this. It's around 17496 pi. So that's the area in the between two functions. Okay, so I hope this is getting better. Check it out, what we're doing, and then you can get it. One last one. I'm going to go down slowly. So same thing, we are rotating x-axis. Ooh, two functions. So we're going to use this formula again. So what are you guys going to do? In this, which one is higher? This is higher than this one. So which is this function? This is going to be y equal to radical 3x. So in this function, we don't have f of x function. So you have to solve for y, okay? So you're going to solve for y. So the first one, 3y equal to x to second. If you solve for y, x to second over 3. So f of y equal to x to the third over 3. So this is f function. Same thing, y second 3x. So we're going to solve for y. So y, if you put the radical 3x. This is the g function. But we don't know which one is a g or whatever. So now I'm going to just say, I'm going to get rid of it for a second. So we're going to define it. So anyway, we solve for y. We solve the y for y. So now we define that this is a higher, this is a radical 3, this is the radical, this is a quadratic. So this is a higher height, higher height. So this is going to be g function. So this is going to be g, y. My bad, this is going to be f because it's a higher. This is f of y. Sorry, f of x. Why am I doing f of x, right? Because it's a rotating x-axis. This is going to be g of x. Are you following? One more time. When you look at this image, the height of this function is higher than the bottom one all the time. And then this function is not a great form. You need to solve for y so that I found out what the y equal to something, what the y equal to something for both equations. And then when I check that, the second function is a higher, height is a higher, so that is going to be f, this is going to be g. Now you're going to plug into all the equations. Volume. And then do we know the a to b? No, we don't know. So we're going to find out first. So from where to where? From here to here to find a to b, f of x equal to g of x. So you're going to solve for x to the second over 3 equal to radical 3x. And then if you solve it, I'm going to square second power on both of sides. So x to the 4 over 9 equal to 3x. And then you're going to multiply 9 both of sides, right? So that it's going to be x to the 4, 27x divided by x. X to the third is a 27. Gotcha. X is going to be 3. So from 0 to 3. So this is a 3,0, as you see that. This is a 0,0. So based on that idea, we collect volume pi from where? 0 to 3. So this is a rotation around the x-axis. So we're going to subtract f, which is, this one is now f, radical 3x second power minus g, x second over 3 second power, and dx. And then pi 0 to 3, so cancel, 3x minus x to the 4 over 9 dx. So that means take the integral, so 3x second over 2 minus, this is 1 over 9, x to the 5th over 5 from 0 to 3. So pi 3 over 2 x to the second, 1 over 45 x to the 5th, 0 to 3. So now capital 3 minus 0. So then pi 3 over 2, 3 to the second, minus 1 over 45, 3 to the 5th, and the rest of it thing is a 0. So once you calculate it, 9 times 3, 27 over 2. This is a 243 over 45 pi. If you don't like it, you can change it to decimal, but it's going to be around 81 over 10 pi. Check with the calculator. So you can find out the volume between two functions by using the washer method. So I'm going to highlight it one more time. So this is a washer method. When you're rotating around x-axis, if you want to rotate y-axis, the formula will be, we know, volume, C and D, pi. You can write down pi either front or where. So I can write it here. Pi C and D, f of y square minus g of y and dy. So there's two cases for each disk and washer method. We're gonna, whether you're gonna rotate x-axis or y-axis. So here, I when you wrote down x-axis rotation, think about the y-axis rotation as well. Okay, so that's all about 2.2. And you can finish all the quizzes. And if you have any question, email me or go to participation discussion board, help each other. So in 2.3, in the next video, I'm going to talk about another approach to find out the volume, shell method. So hang in there, we're going to get there. But so far, you master what the disk and washer method, and you know the commonality and differences. Check, check, check. Okay, so I will stop here. Thank you everyone for staying. I will see you in the next video. Bye-bye.